Formation of rainbow in the sky. So rainbow is a natural spectrum. Rainbow is a natural spectrum. Actually, it is produced by the water drops. So always the rainbow appear just opposite to the sun after the rain. After the rain, there will be millions of raindrops in the sky. So each water drop it is acting like a natural prism and is splitting the sunlight into seven colors that is forming the rainbow just opposite to the sun. So how the water drop, it is splitting the sunlight. We can see that the light is falling on the raindrop. It is split into when light enters the raindrop, it will be bending towards the normal. So the red light it bend like this, and the blue light it will be bending like this. It is getting refracted. After the refraction, internally it is reflected again, reflected internally. So it is reflected like this. So after the internal reflection, it will be emerging out. It come out of the raindrop. Always the blue color it will be at the top, the red color it will be down. So this is the way the phenomenon of refraction and reflection. Refraction and reflection, internal reflection, it is responsible for formation of rainbow. Actually, one single drop cannot make a rainbow. So there are number of raindrops. So how do we get the red color at the top? Let us see. So suppose the s- sunlight from one, actually we see the two raindrops. So two raindrops splitting the light, and the red light it reaches our eye from the top of the raindrop, and the blue light reflected and refracted by the another drop it is reaching our eyes. So this is the way we are able to see the red light at the top and the blue light at the bottom. So this is because of two water drops just above and below is refracting the light, right? So single water drops is not enough to make a rainbow. So that there will be number of raindrops which is refracting and reflecting the light rays. So those all the light rays, it is reaching our eyes as a red light and red color, and the number of raindrops here, it is refracting the blue light. It is reaching our eyes. So that is the reason we are able to see the red light at the top in the rainbow and blue light at the bottom in the rainbow. So number of millions of water drops refract light, and the light will be splitted by refraction and reflection, internal reflection, and it is forming a rainbow on in the sky. The apparent position of the stars, apparent position of the stars, and how the stars twinkling. Let us see how the stars twinkling and the apparent position of the stars. Actually, the this is the Earth. This is atmosphere. So atmosphere has particles, the mixture of gases. The stars are here. The light from the star, it is entering the atmosphere. When it is entering, there will be a mixture of gases. So the density of the atmosphere, it makes the sunlight makes the star light, it bend like this because the speed of light, it decreases. Speed of light decreases when it is reaching the atmosphere. So there will be, if we are producing this light, this position, the star will be appearing little just above the real position. This is the real position of the star. Real position of the star here, it is appear little higher. This is apparent position of the star. So this is because of the refraction of light in the atmosphere. So why do the stars twinkle? The twinkling effect of star actually, when the light enters the atmosphere, so the atmosphere is like this. It has number of particles, dust particles, air, mixture of gases, everything it is there. When light enters, when light enters here, it continuously, it bends like this. Because of the temperature of the atmosphere, it will be changing, and the density of the atmosphere also, it keep on changing. So temperature and density of the atmosphere, it will be keep on changing. So because of this fluctuation or atmospheric changes, the light bends many times. The light bends, it fluctuates, and it is reaching the person who's here in the earth. So he is able to see the twinkling stars. So the twinkling effect of stars, it is because of the continuous refraction. So the temperature and density of the air, it keep on changing. It is changing the refractive index. uh, Refractive index. So the light from the stars, it bends many times, and after bending, it reaching the surface of the earth. So it causes the twinkling effect of stars. So stars, sometimes it looks bright, and sometimes it will be looking very dim. But if you are seeing a planet, so if you are seeing a planet, we are not seeing the twinkling effect because it is larger in size. Planets are closer to us, so it is larger in size. So the stars are like this means if you are seeing a planet closer, so it will be larger in size. So there will be number of smaller spots like this. If you are making a smaller spot like this, one smaller point-sized particles are here. So some will be bright, some will be dim. So all together, some will be bright, some will be dim as the size is larger. Size is larger. It is looking as a whole, it is looking so brighter. So there is no twinkling effect of planet. So planets are, it is showing only the bright light. Because of this reason, it is showing only the bright light. It is not twinkling. So Hubble telescope, they are sending actually, it is orbiting the Earth. It is orbiting the Earth. It is orbiting the Earth outside the atmosphere so that it is able to capture the exact picture of the stars and the planet because the light directly it is reaching the Hubble telescope. So without the intervention of atmosphere, it is able to take the pictures clearly. So from the Hubble telescope, if we are taking pictures, it is not twinkling. The stars are not twinkling because there's no atmosphere over there.